Is creatine only useful for resistance or power type activities? Well, there's a growing body of evidence suggesting that creatine supplementation may also provide beneficial effects for other activities. Creatine has been found to promote greater glycogen storage, which directly promotes recovery and preventing overtraining. Creatine may also help athletes recover from intense exercise and/or tolerate intensified periods of training to a greater degree, as evidenced by a 2009 study in which individuals supplementing with creatine experienced less muscle damage, inflammation, and muscle soreness in response to running 30 kilometers as well as 4 weeks of intensified training. Thirdly, there is evidence that athletes who supplement with creatine during training experience fewer musculoskeletal injuries, accelerated recovery time from injury, and less muscle atrophy after immobilization, though it is unclear whether this is due to a greater resistance to injury and/or the ability to recover from injury. Fourthly, there is such compelling evidence that creatine is neuroprotective that the International Society of Sports Medicine recommends that athletes engaged in sports that have a potential for concussion and/or spinal injury take creatine for its neuroprotective effects. And lastly, creatine may reduce the risk of heat-related illness when athletes train in hot and humid environments, which may be surprising to those under the impression that creatine causes dehydration. Because creatine is an osmotically active substance, it is speculated that it can cause dehydration, cramping, and electrolyte balance during exercise and/or in increased environmental temperature. There's a fair amount of anecdotal evidence in support of this from self-reported surveys, but they are in contradiction to experimental and clinical evidence, such as in one experimental study that monitored 72 NCAA football players throughout a football season and actually found the creatine users to have less cramping, heat illness and dehydration, muscle tightness, muscle strains, and total injuries than the placebo group. And in a clinical study of hemodialysis patients who frequently reported muscle cramping, the experimental group, who was provided creatine 5 minutes prior to hemodialysis, experienced a 60% decline in muscle cramping. So while there is an abundance of anecdotal evidence of creatine causing dehydration and cramping, experimental and clinical research does not support the idea. And these findings should come as no surprise when we think back to osmosis and realize that creatine is stored within muscle cells. Osmosis will actually cause water to be drawn into the muscle cells, hydrating them.